All right, let's look at another problem, moment about a point or moment about an axis. There's an axis in it, but we'll see how we can solve it from moment about a point. In this problem, force F is applied to the handle of the valve as it's shown. Its moments about the x and z axis are given. M sub x is minus 77 pound-foot, M sub z minus 81 pound-foot. D is given as 27 inches. Determine the moment M sub y of F about the y axis. So this problem might look like a moment about an axis. You got to find moment of this force about an axis. But we'll solve it a different way. We'll find a moment about a point and then find the components of that moment about a point. And I'll tell you what I mean. So let's have point O. Let's have moment of that force about point O as a vector. It's going to be cross product of two vectors, R cross F. R is position vector from point O to my force, or line of action of the force. So it's from O to anywhere on the line of action of F. I'm going to take point A and force F. This will be a vector such as this one, M sub x in I direction, M sub y in j direction, and M sub z in k direction. Okay, so each of those components is moment of that force about axis x, axis y, and axis z. And these are the ones that the problem has given us. So this one is minus 77 pound-foot. This one is what we have to find. And this one is the minus 81 pound-foot. So same as before, we have to find two things. It's kind of like this. We have to find R and F. This case, this will be inches, this will be pounds. So the components of R, they go in the second row. The components of F will go in the third row. So let's just start by finding each of those. We can start with by any of them. Let's just start with position vector. Point A, point O, X, Y, Z units are inches. Well, I should say units, but I said inches, units. Point O is located at 0, 0, 0. Point A, all the information is given. It's 4 in the negative direction, so minus 4 inches. Y going up, so that's positive, positive 11. And then D is in the opposite direction of Z, so that's minus 27 inches. So R, position vector, OA, O got to be subtracted, or O got to be subtracted from A. So that will result in 4I. Well, that would be minus. And then 11 minus 0. 11J, and then minus 27 minus 0. So that will be minus 27K. And these are all inches. So these three will go right here. Now we got to find components of F. I have a video on how to find component of a force with transverse and azimuth angle if it's given. So make sure to watch that video. I'll go over it really quick here in this problem. F in vector form, Theta is an angle that it makes with a z angle with z x-axis, xz or z x-axis, and then the phi is the angle that the shadow of f makes with x-axis. So the vector in 3D form or components is going to be f. This is component, or sorry, magnitude, cosine theta, cosine phi, and this is going to be I, f sine theta, that'll be j, and f cosine theta sine phi, and that'll be k. So again, if you're confused on this part, make sure to watch my lecture video plus examples that I've done on component of a vector when it's located like this. So let's put everything back in the matrix again. I, j, k. We had -4, 11, -27 inches. F cosine theta, I'm just going to put C and S. Cosine phi minus, that's going to be F sine theta, and F cosine theta sine phi. Okay, so let's do, again, I have an example on how to do this one, but eventually you're going to be, if you do the math, you're going to end up with F 11 cosine theta sine phi minus 27 sine theta, and that's going to be your I, plus F 4 cosine theta sine, sorry, that should have been theta, theta sine phi minus 27 cosine theta cosine phi, and this is J, plus F 4 sine theta 11 cosine theta cosine phi will be a result of this determinant. Remember, from this matrix, sorry, from beginning, the I component was -77. So this here, change color to it a little bit. This one is 77, and that's negative. This one is what we have to find, and this component, sorry, I forgot a K there. I'm going to add a K there. That was minus 81 pound-foot in this one. Okay, so at this point is a little bit of algebra, a little bit of math. I can just write it very quick, but you can skip to the end of it to kind of see the end result of it. Because we have cosine theta sine phi, and we have cosine theta cosine phi, we have to find these two from the other two equations. You see, cosine theta cosine phi and cosine theta cosine phi and cosine theta sine phi are showing up in the other two equations. So again, if you want to skip ahead, that's fine, but your cosine theta sine phi is going to be your mx minus 77 over 11f 27 sine theta over 11. And then your cosine theta, cosine phi is going to be 4 sine theta over 11 minus 81 pound-foot over 11F. So we got to replace these two in y component, which was this, cosine theta, cosine phi, cosine theta, sine phi. Okay, so this one is going to go here, and this one is going to go here. So you end up with, I've done the math here, you will end up with m sub y being minus 226.8 pound-foot as your final answer. Again, please leave a comment if you have questions, or reach out to me about the math part of it. But again, it's a little bit of math at the end to figure this out. So, but this was a smart way of using moment about a point, which we defined a point O right here. Find moment of about point O, and kind of using that to our benefit to find one of the components or moment about one of the axes. Thank you very much.